Okay, so let's do this question. Okay, find the current through the 8 ohm resistor. Okay, so I'm going to do this problem using Norton's theorem. So here we first, as usual, the same way how we do for Thevenin's theorem, we look for the load. So here the question is with regards to the 8 ohm resistor, which means you need to treat this resistor as your load, which means you need to remove this resistor. And since you are applying Norton's theorem, after removing this resistor, you short the two terminals. Okay, so which means after removing and shorting them, let me write that the resistor, I haven't written the resistor value. The value of the resistor is let me see, 5 ohm. Okay, the value of this resistor is 5 ohm. Have I missed anything else? Okay, no. So remove this resistor, okay, and then short it. So removing 8 ohm resistor and shorting them. Okay, shorting them. So what you get is let me redraw the circuit. You have a voltage source, which is basically 20 volt. 20 angle 0 is 20 volt. Okay, and then you have a resistor over here. Okay, and over here what basically happens is that, okay, I'll draw it another pen just so that you won't get confused. Okay, so basically there was a resistor over here. I removed the resistor, and since you are applying Norton's theorem, after removing the resistor I short them. Okay, this is A and B. So now A and B are now shorted together. Okay, now this is a single connection. Okay, and the current flowing from A to B is called as the Norton's current, which is the current you need to find. Okay, this is basically what happens. Okay, this is another resistor, and this is another inductor. Oh, I forgot to draw the inductor. Okay, so this is 4J, this is 10 ohm, and this is the current source. Okay, there you go. Okay, this is the current source. This is 5 angle 0 degree amperes. Okay, this is 5 ohm. So now you basically what you're going to do is that you are going to apply mesh analysis. That is what you're going to do over here, right? You're going to apply mesh analysis. So after finding the mesh analysis, what I basically do is I need to find the value of IN, right? So if this is mesh analysis, there are 3 meshes. So this is I1, this is I2, and this is I3. Okay, so I found the value of I1. So I need to find here I1, I2, and I3. So now, but the thing is, I need to find the IN. I only need to find the Norton's current. So what is Norton's current? Norton's current IN is the current through this branch. Okay, and according to your mesh currents, what is the current through this branch? You see, this current I1 is flowing downwards, right? The same direction as IN, and another current I2 is flowing through the same branch, but it is flowing in the opposite direction. It is flowing upwards. So which means the value of IN is I1 minus I2. That is the current through this branch, right? The current through this branch is I1 minus I2. Why it is I1 and minus I2 and not I2 minus I1? Because IN is flowing in the same direction as I1. So therefore I1 is positive and I2 is flowing in the opposite direction of IN. That is why I2 is negative. That's why the equation for IN is I1 minus I2. Okay. So what you basically do is when you are applying mesh analysis, you need to find the value of I1, you need to find the value of I2, and then you need to subtract those two currents to find the value of IN. So let's do this equation. So first I will start with the equation for mesh 1. Equation for mesh 1. Okay. So according to this equation, this I1 is touching only this element over here, this resistor. There is no other element except this. So which means it is I1 into 5. Okay. I1 into 5. And what about I2? I2 is not touching any element. There is no resistor or capacitor or anything over here. So I2 is not touching any element. So it is I1 into 5. Okay. I1 into 5 is equal to 20. I1 into 5 is equal to 20. This is the only equation left. So which means I1 is equal to 4 amperes. So now I found the value of I1. Okay. I found the value of I1. Now next is equation for mesh 2. equation for mesh 2. And if you look at this equation, here I1 is not touching any element, right? I1 is not touching any element of mesh 2. These are the only two elements of mesh 2, and I1 is not touching those two elements. So therefore I1 into 0, okay, minus I1 into 0. Next is I2. I2 is touching these two elements, right? So therefore it will be plus I2 into, this is 10 plus 4j, right? This is 10 plus 4j, okay, I2, right? And minus I3 is also touching the same two elements, right? So it is minus I3 into 10 plus 4j, okay? And also there is no current or anything of that sort over here, right? There is no voltage, sorry, there is no voltage source over here, right? So therefore this is equal to 0, okay? Or if you look at this, basically means that I2 minus I3 is equal to 0, or I2 is equal to I3. We can write that also, right? I2 is equal to I3. This is the equation for mesh 2. I2 is equal to I3. Now I am going to write the equation for mesh 3, okay? The equation for mesh 3, okay? So now if you look at this equation, see, basically this equation is very simple, okay? Look over here, that the current through this branch is I3. It's flowing downwards, right? But already there is a current in that branch which is flowing in the opposite direction, and that current is called as 5 angle 0 or 5 amperes. So therefore we have in the same branch, you have a current called I3 flowing downwards, and the same branch is having a current called as 5 amperes flowing in the opposite direction. Therefore the equation for mesh 3 is I3 is equal to minus 5. This is the equation for I3, okay? So if this is the equation for I3, your job is to find the value of I1 and I2. I1 I already found, it is 4 amperes. I need to find the value of I2, but I2 is equal to I3 and I3 is equal to minus 5 amperes. Therefore I2 is equal to minus 5 amperes. This is the value of I2. I2 is equal to 5 amperes. So therefore IN, Norton's current IN, right? IN is equal to I1 minus I2, which is equal to I1 is 4 amperes minus, and I2 is minus 5 amperes. So it's like this. So this is equal to 4 minus of minus is plus, so it is 4 plus 5, which is equal to 9 amperes. This is the value of Norton's current. Norton's current is 9 angle 0, okay? 9 amperes is nothing but 9 angle 0 degree amperes. You don't have to write like this for your understanding. Next I am going to find the Norton's impedance, okay? So to find Norton's impedance, if I see any voltage source, I am supposed to short it, and if I see any current source, I am supposed to open it. So I need to short this voltage source and I need to open this. So opening this current source means then this entire mesh will disappear, right? Because no current will flow through this mesh, so this entire branch will disappear. So you have your circuit will become like this. That is, this side will be shorted. Then you have a 5 ohm resistor, okay? Then you have basically the open terminals A and B. This is A, this is B, okay? Then you have the resistor and the inductor. This resistor and this inductor. This is 10 ohm and this is 4J. This is 10 ohm and this is 4J, okay? And this current source is open, right? So you don't have to draw this. So this is the circuit. There you go. This is basically circuit. Resistor is 5 ohm, okay? If I found, I've just simply joined these two elements into a single device. So how does it look like in that case? Let me redraw the circuit like this, okay? This is Zn, right? The terminal across A and B is the Zn. So this is Zn, and here you have one element and you have another element over here, and this is another impedance, and this is called as 10 plus 4J, and this is 5 ohm, right? And this is Zn. The terminal between A and B is Zn, okay? So now if you look at these two elements, this 5 ohm and this 10 plus 4j, if you look at these two elements are actually parallel to each other. See, look at this end of the resistor. This end of the resistor is connected to A, and this end of the impedance is connected to A. Likewise, this end of the resistor is connected to B, and this end of the impedance is also connected to B. See, so therefore these two elements are basically in parallel to each other. Therefore Zn is equal to 5 into 10 plus 4j by 5 plus 10 plus 4j, or basically this is actually 5 into 10 is 50 plus 5 into 4 is 20 j by, this is 5 plus 10 is 15, so 15 plus 4j. Okay, so therefore Zn is equal to, this is 50 plus 20j, 50 plus 20j divided by, this is 15 plus 4j, 15 plus 4j, 50 plus 20j by 15 plus 4j, and you will get the answer as, this is equal to 3.444 plus 0.415j. Okay, this is the value of Zn. If you are writing in polar form, it will be 3.469 angle 6.87 degrees ohms. This is the value of Zn. Okay, so this is the value of Zn. So basically your equivalent circuit will become like this. That is, you have a current source which is flowing upwards, and that current, the value of the current source is 9 amperes. Okay, and then you have an impedance over here, and the value of that impedance is, okay, the value of that impedance is, you see, I need to find the current through the 8 ohm resistor. That is my question, right? The current through my 8 ohm resistor, which means, so just for calculation purpose, I will use the imaginary part over here. So this is 3.444 plus 0.415j. Okay, and now this is your Norton's equivalent. Now I'm going to put back my load back to its place, right? Here I removed that load, and then I shorted this to find the Norton's equivalent, right? So now my load is 8 ohms, which means I'm going to put 8 ohm back to where it belongs. So that is this 8 ohm over here. Okay, and what's the question? The question was to find the current through the 8 ohm resistor. So I need to find the value of the current over here. So you can apply any theorem you want. You can apply the current division rule, or you can simply close your eyes and apply mesh analysis. If you are applying mesh analysis, then this is mesh 1 and this is mesh 2, which means the current through this resistor is I2, right? The current through this resistor is I2. So which means you just simply need to find the value of I2. And what is the value of I1? I1 is equal to 9, right? I1 is equal to 9. See, because this is a current source, so basically I1 is equal to 9. So which means now you need to find the value of I2, right? And so what is the value of I2? That is, this is minus I1 into 3.444 plus 0.415j, okay, plus I2 into we have 8 plus 3.444 plus 0.415j is equal to 0. This is the equation, right? This is the mesh 2 equation. So which means basically we know the value of I1. I1 is equal to 9. So this, you put 9 over here. Therefore I2 is equal to 9 into 3.444 plus 0.415j divided by this is the denominator, that is, this is 8 so this is 8 plus 3 is 11, right? So this is 11.444 plus 0.415j. This is the value of I2. So that is the current through 8 ohm resistor, right? So which means, let me see, it is 9 into 3.444 plus 0.415 J, close the bracket again, divided by, open the bracket, 11.444 plus 0.415 J, close the bracket. Okay, so you will get the answer as 2.717. Therefore I2 is equal to 2.717 plus 0.228 J. This is the value of I2. Therefore current through the 8 ohm resistor is equal to 2.717 plus 0.228 J, or this is also called as option, convert to polar form. So this is also called as 2.726 angle 4.794 degree amperes. This is the value of the current. Okay.